Hey class, Mr. Bean here. I've been asked to maybe kind of go over, give some hints for simulate. So this is lab number 9 for AP Physics here, and we've been asked for some hints for simulation number 5, number 7, and also number 9, crossing the river. All right, so let's go ahead and take a look at number 5 here. Let's jump right into number 5 here. And let's see what it says here. Okay. So it says average versus maximum velocity. In this activity, your car will start from rest, accelerate to a maximum velocity, stay at that velocity for a bit, and then slow down until it stops. From the position versus time graph, you are to determine the average velocity for the entire graphed interval and then the maximum velocity of the car. When you are ready to start, go ahead and hit the begin button. So go ahead and hit the begin button here. And so here we have a position versus time graph, and it says here, click on the car to start the motor. So we'll go and click on the car here, and let's see what happens. And we're being tracking this motion here. Okay, take a quick look here, and let's see what's going on. Okay, still accelerating. Okay, and now it's coming to a stop. All right. Okay, so what are we asked to do here? It says your name, of course, average velocity for 30-second interval, and the maximum velocity. So let's do the average velocity first. Okay, so I'm gonna make a note to myself here that average velocity here. Go here. It should be was it final position minus initial position here, right? Divided by the time interval. Okay, so over here, what's our final position? That's right here. Here's our final position right here. And it kind of looks like, according to this diagram here, we're 2 up from this mark here. So this is like 350, 360, 370. So it kind of looks like 370 here, right? 370 minus, was it initial position here? It looks like, boy, okay, so this is what, 10, 20, 30, 40, 50. So 50 here, there's 50, and make sure this is a 7 here. And the time we start at, this is 30 seconds here. Okay. And the final position was, yeah. So minus a 0. All right, let's go ahead and do that and see what we get. So the average velocity here should have been, let's see what we got. 370 here minus 50, right? Divided by, let's say, 30. And that should give me roughly 10.67 meters per second. All right, so that's our average velocity between this point here, right? This point right here and this point right here. So this is our initial position here, and this over here is our final. So this is our final position here, and our initial position is right here. Make it a little bit better. All right, so go ahead and follow this during the 30-second interval. All right, now it says here, okay, so using a section of graph, when is it moving the fastest? Okay, so let me go ahead and use, let's use blue here. And it looks like it starts to, so we have not moving, now kind of speeding up here, right? There's a little curve here, right? There's a little curve here. So it looks like it's kind of speeding up here, and it looks like it's accelerates. So this is a curve here, right? Well, this is a curve here, so it's a kind of accelerating here, right? And then it seems like about right here, it kind of reaches is kind of a straight flat. So it looks like this part here is kind of like average. Or it's kind of like moving at a constant rate. Then it begins to slow down here. So it accelerates at this point here, and then here it kind of looks like it's already at its maximum velocity. So basically here to find V max right here, right? Uh, we need to find the slope of this line. So what is the slope of this line? Okay, and that should give us our maximum velocity. Okay, I'm gonna go hit pause. Okay. All right. So next up is simulation number 7, finding maximum velocity or finding maximum velocity. So let's go ahead and kind of let's go back here And we want to be number 7 is finding maximum velocity. Let's go ahead and go here, and let's see what's happening here. We'll hit begin. Okay, there's some reading here. And okay, determine the time when the car hits maximum velocity. Okay, let's click begin, and let's go ahead and start the motor here, and let's see what we got going on. Going pretty fast, beginning to slow down here, and okay. All right, so use the graph above to find the moment when the car reaches maximum velocity. All right, so here's so we want to so basically it's at what time is it its maximum velocity. So we don't look at the slope here of the curve. We want to look at the slope here. Okay, where do we have the steepest slope? Okay, now see how it's begin. Okay, so here it's going up now. It's beginning to go down. So look at the slope here. The slope is getting steeper. So like here, it's getting steeper, 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 steeper. Now it's beginning to right here, beginning to fall. So I'm thinking about right here is the maximum, right here, and that's at 4 seconds. Okay, it's at 4 seconds there. So let me kind of go over. Well, let's see. Let's kind of put it right there. There's 4 seconds, right? So there's 4 seconds. So let me kind of there we go. So I'll go over here, use my pen. So I need to find the slope of the line at this point right here. Whatever the slope is, that's going to be the maximum velocity in this situation. Because after this point, the curve or the slope begins to flatten out. Okay. All right. We'll hit pause here. So the next one here is crossing the river. Okay, let's go ahead and take a look at this one here, crossing the river here, and let's kind of see what's going on here. All right, so we are here, and so we can kind of see what's happening here. So we have a velocity. This is 7.1 meters per second going in this direction here, and the river looks like it's moving at 5 meters per second this way. And this distance here is 42.0 meters. Okay, and so there. Let me go and get a pin here, and let's go and go with black. Okay, so there are two diagrams to consider. Okay, there's going to be a we call it here. There's going to be a velocity diagram and a position diagram that we want to consider. Okay, we'll do velocity over here, and we'll do position over here, just so we can kind of see what's happening here. Velocity, and here is position. All right, so get rid of this. Okay, so with velocity, let's see what we got here. So here, okay, so I'm just concerned about the velocities here, right? So we're over here, and then so we have this vector right here going like this, okay, and this velocity here is 7.1. So this is going to be 7.1 meters per second. Okay, that's okay. Then we have a vector going this direction like this here. Okay, and this one here, according to mine, so according to this one here, is going to be 5 meters per second. Okay, all right. So what we have here now is go and take a look here. So I'm going to go ahead and draw the dashed line. Okay, this is going to be the resultant vector. Okay, so we might need to know what this is here. Okay, so this is like the hypotenuse here, and maybe we'll call this maybe vector A. Okay, we'll call this vector A here. Okay, so what is this vector A here? Okay, so it's vector A, or what's the magnitude of this vector A here? So if I do that here, that should be, okay, it looks like it's the hypotenuse here. So it should be 5 squared, right, plus 7.1 squared. Okay, and that there gives me what this one here is. In fact, let's go ahead and just do that anyways. So I'm going to go ahead and do the square root, right? And we're doing 5 squared plus 7.1 squared, and that gives me 8.68. So this vector here is 8.68 meters per second. All right, now, so the problem is that, okay, so if we were to go straight, so if I do this here, according to diagram, this is going to probably end up kind of over here, right? Okay, so we need to figure out what is this distance right here. This is what we want to find out. What is this distance here, right? Now, we already know that from here to here, this distance is 42 meters, right? So I'm kind of go over here and draw this position over here. So we know going straight across this way, this is 42 meters, right? Okay, and we have this velocity vector here like this, and this distance right here is what we want to find. What is this distance here? Okay. All right. So question is, we have velocity here and we have position here. What we need is time. Okay. If we had time, I think we might be in good shape here. So how do we find time? Well, we know that velocity is equal or speed is equal to distance over time, or velocity is equal to distance over time, or that's or displacement over time. Okay. Or you know and so what we can do here is take a look here and say, well, here I have velocity, velocity, velocity. So I want to find out what's the okay. So the time it takes to go from here to here is consistent, whether I go straight across or this time here and this time here to reach across is going to be the same time. So I need to find the time. So what I might do is take a look here. See this 7.1. So if I go over here, so I have speed here is distance over time, right? So let me go over here. So time now, here's time. Time is going to be, was it, is going to be, was it distance divided by velocity. So I want to know what's the time to cross this river here, okay? To either go this way or to go this way. What is the time to get across the river? So that's going to be the distance, which is in this case 42 meters, right? Divided by, in my case, 7.1. Here, 7.1. Okay, so if I take 42 and divide it by 7.1, that's going to equal, according to my calculator, 5.9. So this is going to be 5.9 seconds, okay, to go from here to here. Okay, all right, so 5.9 meter for 5.9 seconds. Okay, all right, so I go over here and let's take a quick look here. So over here, I want to know. So if I have distance, uh, so we have here velocity speed is equal to distance over time. Okay, I can rewrite this as distance is also equal to velocity times time, right? Okay, so over here, okay, I know that this is 42 meters, and I know what the speed is here, so I can do distance is equal to velocity times time. Okay, velocity times time. So the distance here, this distance is going to be whatever the velocity is, which was 8.68, right? Meters per second. I'm going to times it by the time it takes to get across the river, which is 5.9 seconds. So here's 5.9 seconds. So this gives me the distance here. So now I have this distance here, okay, and here's my right triangle here, right? Here's theta. So I need to figure out what this is, right? So I could probably use the Pythagorean theorem to figure out what this distance here is. All right, go ahead and give that a shot, and if it doesn't work, give me a holler.